raised a whole bunch of questions for us around security and access, and caused a whole lot of problems, which resulted in something called HIPAA, which was a large hippopotamus that fell in the middle of the room and stopped all data exchange for at least 5 years until we figured out what to do with it. Also the realization that we had large amounts of digital data caused also the security threat to systems that held it from us who wanted to access it. I bring that up because technology created those problems, at least we see as problems in the healthcare world, but technology, architecture, and software, I think, is also the solution for those problems. And one of the topics that I'd like the folks on the panel to think about is how architectures specifically address those issues created in the small domain of medicine, among other things. Actually, I'll leave it at that. Just ask him to, because I'm not chairing this panel, Jeff is, and hopefully he can stimulate the other panel members to answer those questions. Also, this is a symposium and interactive. Questions from the audience and assaults from the audience are perfectly welcome. Jeff, thank you.
All right, thank you. I guess I should let you guys comment on that first, because I'm deeply uninterested in that topic. So if I'm going to be chairing this panel and we're going to talk about that, I should probably just get out of the way.
It should not be the whole panel.
But if anyone has something to talk about on that front, how do we get microphones? Do I just?
These are all live. And where's the lavalier? This is not live.
It's okay.
Lavalier might go.
Yeah,
so I could say something about HIPAA. I will say, I'm not that deeply involved in that side of things. My impression, working on the technology side of the realm, is that many of the issues here are more policy-oriented than technical. I mean, we have mechanisms for encrypting. We have various techniques for, sort of reasoning about how much information was revealed. Many of those things are not quite what people are actually worried about at the end of the day when they talk about privacy. I remember talking a couple of weeks ago with somebody who was saying that, so he was a computer scientist and he had just had a conversation with a lawyer, and the lawyer was saying, when people talk about privacy, they're not actually so concerned about whether any information was revealed. They were concerned about whether someone who has access to that data in some sense has power over them, whether it's to humiliate them, it's to extort them, it's to make money off them or whatever, that's really at the heart of what people are worried about. So, if you think about it that way, then it's not at all clear what we really want out of enforcing or measuring privacy. So, my take on all this is that most of the real issues here are related to the fact that we don't quite understand what we really want. I don't think there are that many technological problems.
There was a question earlier, I think when Chris Mountain was talking about the topic of data sharing, and the topic was, what are the rules, or is there a way we can start to look at open data sharing and so forth? One of the things we did with our National Cancer Institute project was we actually developed a common protocol for data sharing at a national level. And so rather than having each group go off and submit to their own institutional review boards their own protocols, we wrote one protocol. We embedded the architecture in that protocol, and our feeling was that rather than trying to figure out how everybody have their own versions or implementations of that architecture, we wanted to get everybody at every institution to agree to the same perspective. And that actually worked really well for us, because as we added 2, 3, 4, 5, all the way to 15 sites that were sharing data, we had a lot of momentum that said, we had, University of Colorado and Fred Hutch Cancer Center and Johns Hopkins and, University of Texas. We had all these groups that already agreed that we could share the data. And so architecturally, we were able to explain that and explain how we were protecting confidentiality, how we were protecting access, how we were dealing with making sure that institutions could control who could see what data, and we'd push those controls on there, but also provide access to it. And so that was just a good tip for us to realize how we actually set this up. Yeah.
when you fund from the top down. Because if you fund from the top down, you can put requirements in to get access to the funding. When you build the community from the bottom up, it doesn't work so well.
Yeah, the grassroots is a little tougher. Yeah, we had in our case, we had gotten the NIH behind it, and that helped substantially in driving it. Yeah, that's right, driving the more national picture. Yeah.
I realize we probably don't want to say too long on this, but so one of the things that I found, so I work more with sort of scientists who have research labs who are getting PhDs than clinicians. My impression is the problems for data sharing between the clinicians and the lab scientists are very, very different. So the clinicians, the big problem seems to be HIPAA and such things. The domain scientists, that's not the problem. The problem is, I have my collection of data that I spent, blood, sweat, and tears curating for a long time, and I want to milk it for every paper that I can get. And I am, of course, being, somewhat overdramatic here, and so what credit do I get for giving this away? And, when I look at my credentials, my CV for getting a job or for getting tenure or for getting promotion or whatever it is, right? In general, we do a poor job of incentivizing and recognizing the effect of sharing. And I think that's actually one of the big things. So one mechanism for helping is indeed, NIH or somebody with a lot of money or the CTO or somebody like that, either with money, which is the carrot, or, iron fist, makes them share. But, my impression talking with a lot of lab scientists is that, even these regulations about putting data up so that, it can be, so that you can publish, basically everybody, writes these things into a central file system, but they don't bother to give any help on how to actually read it back out. So basically, it's the sort of going through the motions of writing some opaque thing and not really helping because there's no incentive to do that. So, even making people share the data doesn't really make them share the data. It just makes them put it somewhere. And so I think, we need to actually address that in a much broader way as a community. And I think it's not just the medical community. This is true across almost all of the sciences, including computer science. We just don't have good reward mechanisms for being a good, helpful citizen and sharing. I think people are trying to work on that, but it's still a big problem all throughout.
Cool. Any other topics that people want to talk about? Go ahead, John.
So I wanted to agree with you as far as the basic philosophy. I was at Yahoo before they fully switched over to HDFS. And at the time when I first came, most data was in databases, which were terrible because people had access to them. And the way in which you could read data out was maybe like twice per time. You come up with this absurdity, make a mistake, you have to start over, and now you basically can't go back in time far enough. So having an open system of the sort that you talked about is game-changing. And I expect that an open system of that sort will eventually arise in the medical domain and become standard, and it will be game-changing. And then the question is just how do we get there?
Would anyone else like to praise me? Okay, yes. Anybody else have questions or comments? Oh, down here.
Just curious, so two different systems were described, and if we wanted to set something up from scratch, and say, for example, the kind of things you described about in the Facebook system that you set up, how much time would it be and how much effort would it be for someone who's video but doesn't do this?
Okay. So the question was, how much effort would it take to set up systems like those presented today from scratch? Yeah, well, I can comment, I guess, on my experience at Facebook, which was we had implemented a traditional data warehousing architecture. The process of bringing in Hadoop and getting it up and running and actually doing non-trivial applications on it, it took several months in that, we had a summer intern. So I set something up at the end of probably 2006 and started playing around, proved out an initial application. In the summer of 2007, we brought in a summer intern. to start doing some more non-trivial work and actually putting in large amounts of data. And then it was probably early 2008 when we actually moved our production data warehouse over from Oracle to Hadoop. So that was about a year and a half. I'll say that my experience with customers at Cloudera is, it can take like a day. I mean, like we now have tools. It's literally like one-click deploy. So we have tools that essentially manage the whole menagerie of daemons which have to be deployed to get a whole cluster starting. And you basically you put in the IP addresses, you install, you get passwordless SSH working, and then you basically check boxes in terms of what you want installed. And then data import is can take a few hours to identify the data sources, identify the tool that can be used to push that in, and then to subsequent querying. So probably a day to a week to get a real live pilot up and running and running queries against it is what we see on customer sites now.
Either way, I can take both. But I think one of the things, we found this certainly at JPL, a lot of our projects, is that for us, deploying the technology, we did this for EDR, and we deployed this at several sites, was simple. We could get things up in a day. The challenge was changing the culture to get people to actually get their data out, identify it, figure out what they have, how are we actually going to use it, all those kinds of things. And that, to me, is where your schedule driver is really what's your application problem and how do you plan it and how do you actually work with the group. And so that to us is just a big schedule driver because I think these technologies are there. The open source capabilities are there. We just need to figure out how to actually apply them to the right problem spaces.
Yeah, I have something to add finally. The thing I would add to it too is, the reason too that you can get some of this stuff up and running very quickly is also you have very strong engineers at Cloudera. The Todd Lipkins of the world and stuff. We have very strong engineers on our team. A lot of the expertise, the technological expertise to establish these big data systems, it's not like you grab someone out of the university nowadays. It's getting closer. For instance, a lot of the graduate students that I teach at USC, I'd say 5 years ago at JPL, we'd hire them and it would be 5 years before they were, useful. Other than sort of learning the domain and things like that. I think it's getting a little better now. The technology is helping, but also just the understanding of the shift in approaches for building software systems, where before, building a data system was very sort of, let's do this on a server, a mainframe, or not a mainframe, but, a lot of people doing that to shifting all the way to your laptop now, where you can deploy a lot of these technologies. A lot of the final projects in my search engines class are students deploying these massive technologies on their powerful laptops, and doing things with it, and that's helped sort of to train some of the people. So to go back to your question, Jeff's answer and Dan's answer is appropriate, but I'd also, measure it with, you also need some high quality engineers and understanding of the architecture for that.
And I think what we've seen maybe in the, I'm probably going to offend somebody in this room, and I apologize for that, for even saying what I'm going to say, but I think what we've seen in the medical community is that a lot of your top tier computer science people haven't gone into those areas, and so we've got to see a skill set improvement, I think, across the board occurring to recognize how do we take these technologies and drive them into the hospital. Because I know the computer science guys I know here for the VPICU are off in their corner and they're trying to figure out how to be known at CHLA, and they should be. It should be an institution that has a strong CS capability now because it's a backbone of what needs to be done in medicine.
Yeah, I'll just to add some color to previous comments that I made. That I kind of was flip about how long it takes to get the software set up and data ingest working. But I would say that in terms of how you pick the project, as Dan mentioned, and sort of build consensus, I think it's very important to not try and convert old projects or critical projects. I've learned from kind of building new systems and deploying them within my own organizations and watching it be done in our hundreds of customers that finding a net new project is pretty important, rather than trying to get an existing project moved over to the system. And then also finding something off the critical path so that you don't have like 1,000 people trying, when it's a very, very high profile project, everybody wants a piece and it moves very slowly. So if you find something off to the side. And then a third thing I would add is, a line of business project rather than a sort of advanced technology group project. I've seen an anti-pattern in a lot of places where the advanced technology group tries to stand up the cluster and convince line of business to use it. And the line of business has been sort of polarized against the advanced technology group by saying, like, hey, these guys are constantly just bringing in stuff that's not going to work. So actually finding that person who's the business owner and working with them. And then to Chris's point about sort of hiring computer scientists, we don't send Todd Lipkin in to install and configure the software. He's building the software. I mean, we have massive partner networks. We have a massive partner network of solutions architects. I mean, people from Accenture and IBM and Infosys and Tata have all been trained to install and deploy this. We have a very large training and certification program. So we will certify over 5,000 people to install and configure the software this year, and we're growing that by an order of magnitude next year. So I think it's through people like Todd making the software easier to use, building it, and then it's through partnerships with, so that's kind of the first tier. The second tier is partnerships with sort of technical consultants who then become, that grows your network. And then the third is sort of a really large scale training and certification so that really anyone, not just partners, can learn how to use it. And I think we're fairly far along. I mean, we're sort of transitioning from stage 2 to stage 3 in the Hadoop community today. So it's, in terms of, it's pretty easy to get up and running these days.
So I'd like to add a couple points that are kind of in these directions, speaking as a computer scientist. So, I think one of the great things that is starting to happen, thanks in part to sort of open source software and just sort of more of a general culture of people kind of working together on these big data problems is when I first started off trying to collaborate with life scientists, usually the easiest thing that seemed to make sense was to find, where there already was kind of IT infrastructure because especially in academic research, you can't build an entire vertical software stack that will solve the entirety of the problem, right? You can work on a piece. It's an algorithm or a part of a system that's part of the stack. But, we're not in the business of, writing custom software from end to end, right? So from our perspective, we have to find pieces where we can solve, some kernel of a problem. But, of course, the domain scientist needs the whole thing, right? They're trying to solve the whole problem, not just the kernel. And when I first started, I talked a lot with people in like bioinformatics groups and so on. Okay, and it turned out, in retrospect, I would say that was probably the most difficult point to try to deliver a new solution. And the reason is, you can solve the problem that the IT guys have, but you're also telling them, scrap everything you've done, put my thing in instead. And they just aren't so excited about that, right? So the challenge then is finding a place where there isn't a solution, because then it's fairly easy to say, look, there's nothing here now. We have something. So people are much more willing to give it a shot. And actually, this is where all these open source tools that you can build on to help put together that stack really make a difference, right? It's not just the case now that, you have to build everything. Maybe you can fit it into the Hadoop ecosystem or into something else like it. So basically, I think the world has actually changed substantially from 10 years ago in terms of the prospects of, academic researchers in computer science and people in the medical field being able to bridge that gap and both do something interesting from a computer science perspective and also, relevant and useful from a medical perspective.
So you need to be able to grow this software and evolve it over time, right? And I don't know how things are here in LA or in other parts of the country, but certainly where I'm from, we rely heavily on technical consulting groups and outsourcing a lot of our maintenance stuff. We'll have people come in and install it for us, and have a small team to manage emergency problems, but if there's kind of a big overhaul to be done, we'll bring back in another team of consultants to do this. So as you're talking about this grassroots strategy to do an open source evolutionary widget or multiple widgets, what kind of ratios do you need in terms of how many CS guys do you need on the ground on the staff in order to sustain it?
I was first off, I was going to ask, where are you from?
I don't know that I want to say.
Oh, okay. I'll find out, so. Okay. All right. Well, I think I think one of the biggest things that I've seen, especially in domain science, is to probably have, and I don't know the right ratio in the middle, but it's at least an equal mix of CS people and people that understand the science, and to not heavily favor, for instance, like people that understand the science that picked up a book on Python and think that they're a computer scientist, and to also not heavily favor the people who, are CS people that have never touched real data in their lives. From that. I mean, so at least, I don't know as far as percentages, but, 50-50 to start out with, and then, evolve and, depending upon your data or your needs and things like that, as far as CS and domain.
Yeah, let me say, as we talked about earlier, we developed this data management framework that's used in Earth and planetary science. It used to be that we would probably have 5 or 6 people that would implement the data management functions for a mission. We can pretty much do that with one person now. But that one person is connected to one person on another project, and there's a whole network of people building software and exchanging reusable open source capabilities. And so it's the broader collaboration between all the people that's given us a huge leveraging capability that we can deliver on project after project after project. And so it's no longer the importance of having big teams as much as having some experts that really can go off and infect and grow through collaboration, more and more people. And that's, I think, the power of open source.
I think that was another piece that you said there was that you limited the heterogeneity of the software that you used, so you had a small number of people who were all expert in this piece of software, and I think that's one of the sort of least heralded features of Google's technology stack is that everything was kind of built on everything else. So even though it wasn't the perfect solution to the problem, so their distributed file system had significant limitations. If you had looked at the feature matrix between their distributed file system and whatever IBM or EMC was trying to sell you, it would have been a no-brainer, right? It would have been checkboxes down the page for EMC, and you wouldn't have used it. But that being said, they understood that by building expertise in that and then closing the delta between what their problem needed and what they had, they were able to kind of continually build on that expertise, and so they had a much smaller number of systems to try and understand. And so I think there's what I see happen in a lot of large IT environments is there's this heterogeneity that happens because people kind of, for each problem, they go talk to a vendor, and the vendor is able to show them the feature matrix, which convinces them that, hey, for this problem, our thing is the best. And it makes sense locally, but globally, as an IT strategy, they end up with this huge heterogeneity of software components, and it's very difficult to have human expertise to maintain that. So I think limiting heterogeneity is one good strategy to lower the number of people you might need.
Just to follow on to Jeff's point too, and I think he mentioned this during his talk a little bit, but also having an Jesus, good. Okay, there we go. No, sorry. Okay. Yeah. Also educating your technology folks as far as conferences and the community, because like for instance, if in what Jeff just said, it's very easy for folks to go look at the feature matrix with an open source software solution and not understand the difference between your apertures or your Tikas or your whatever, because they all claim to sort of or purport to do the same thing. But just having a set of core individuals, to maybe bring it back to Dan's point too, is that having a team that understands these types of technologies and from an architectural perspective that's willing to sort of pull in the reins as far as expertise in any of them.
Well, I think you see. I mean, I think that the feature matrix comment's really good. Is that you see these vendors that you use 20% or 30%, whatever the number is, and you keep multiplying that because every one you buy adds complexity, and you're using a fragment of every single one. And look at how much you end up with. You end up with just a hodgepodge infrastructure that nobody really understands the power, and so you go buy something else, and you go buy something else, and it just keeps growing, and it drives costs up in my mind. So.
This is a comment. There seems to be an interesting parallel with the subsequent use of the data as there was with the initial problem of getting the data stored in the first place. We started off with multiple systems that collected multiple types of data, so we ended up with the best of breed philosophy, and we decided, well, let's go with a single vendor so we'll have a single platform. And now as we get ready to leverage the data that's we've been collecting successfully, now we're kind of getting back into this best of breed. They want to turn this widget, they want to turn this widget, and separate projects are developing their separate silos.
I think you're better off than a best-of-breed data storage solution, though. I will say that having a consolidated storage solution and a variety of analysis tools, I think, is better than the other way around. I think that the diversity of people doing analysis leads to naturally a heterogeneous collection of analysis tools, in my experience. John?
So I would make a proposal. So if you leave what I said earlier about where the world's going to go, the thing to do is to experiment in that direction. And the best way I can imagine this working out is if NIH said, all right, we're going to create a data warehouse for medical data. Then they added about 3 instances to whatever call for grants they put out saying, we're interested in people who are going to contribute data to this. It's very important if you have a file like this, you actually get it used, right? So it's critical that you actually get the data into the cluster.
Yeah. And I'll agree with that.
And
Because,
then once you have that, it's going to just slow.
yeah. Right.
There's more data. Suddenly people realize how much of a paradigm shift this can be, and then it will just blow.
I was going to say that for the grants and things that I've seen, and the data sharing requirements for NIH grants, they just say you have a requirement to share your data. So you can stage it on anywhere you want. They don't actually have a service where which you can deliver your data that provides open access to the data. And so I think that one of the things we see in planetary and earth science is we don't say you have to just figure out how to distribute your data. You've got to put your data in the planetary data system, which has standards, which provides open access, which has requirements for how long the PI gets to review before it's released. It has all the tools for how to get data out. And so I think that piece is, really missing.
So, I'm going to at least take the position that I disagree with the notion that requiring people to put the data in one place is going to help very much, because just storing it there doesn't help people get it back out. I mean, I've seen time and again. So, for instance, the Department of Defense tried to require that all of their metadata was going to get stored in a central repository because they were tired of everything being reinvented. Well, guess what? It was a write-only device. Everybody threw their stuff in there because they were required to. Half of the things that they put in, they didn't even parse, let alone anyone use it. So
There's a big difference. The difference is when you have these big data sets, you need to have some sort of big cluster in order to actually do analysis on the data. And that means that if you're putting the data in there, you're not putting it in there as a write-only device. You're putting it in there because that's where you're going to analyze.
I thought you said, though, that NIH requires you to put it in there. That's a bit different than there being a user.
Just put in a few sentences about how we support grants that are going to actually add data to and use data on the cluster.
So let me just add, I still think, right now, a lot of times people are willing to go along with storing their data, but not tremendously helpful in helping others use it. And I think that's actually the broken part in the mechanism, and that's why I disagree with your point, right? We need to figure out a way to actually...
But I think it's before you can even have people sharing your data, they have to have a namespace in which to share.
It's incumbent on NIH to
I agree.
provide the infrastructure to do that.
So what's wrong with the...
Infrastructure and you need the culture. And without that infrastructure, you cannot get the culture.
But I think without the culture, you cannot get the infrastructure. It's chicken and egg.
It's something that NIH,
When NIH has done this,
they could actually maybe start things off, and that would change the culture.
So let me just say...
when NIH has done this,
So let me...
NIH then has to put standards in for what data will get collected.
Yes.
The standards definitely do not.
That's what Jen's saying. I mean, they could do something and an epidemiologic analog.
So that's fine for a specialized database with a clear community. But let me just mention, there exists today thousands and thousands of very large public data sets sitting in Amazon. Amazon has this public data sets service where if you have a large thing that you think is useful, you can ship them a hard drive. They will mount it on their cloud platform. They won't charge you anything. And anyone can come along and write, EC2 or whatever software to analyze that data. But the uses of that tend to be very, very restricted, right? Either it's other people who already, knew about this data set and were using it, or it's some very broadly interesting thing. So, one of the favorite ones in there happens to be the data extracted from Wikipedia, right? So there's lots of computer scientists and so on who are interested in, having access to that. But there's an awful lot of medical data and other stuff there that I don't think is actually being used that much. And so my point is, again, I think it's not just putting it out there. It's creating this culture of reuse.
So having a few lines in the corporate grants which says something about the value of putting the data out and sharing things, I think is a step in shifting culture.
So how about the following? Your chances of getting a follow-up grant are vastly improved if someone else adopts your publicly available data set. That, I think, would make a difference.
Yeah, and I think the other case, I can say, so what we do in planetary science, I mentioned this earlier, is we actually require data sets to be peer reviewed for usability purposes. And then a difference, so if you go to something like data.gov, which I think is not the greatest idea, we put all our planetary data in data.gov, nobody's going to use it. Because nobody knows how to use it. We don't know how to search it. We don't know how to serve it. We don't know how to deliver it in forms that can be brought into IDEAL, MATLAB, and all these things. So you need to have a domain-specific repository capability in the services that make the data more useful. And you need to have the community involved in how do you actually architect that in a way that makes that data useful for science. And that's
Sorry, I don't think we've heard from you yet.
So I have a question because I've worked with small data sets from 3 different hospitals, and on top of that, from the monitors versus the clinical data, and just something as simple as a date on each one of those data sets was different. So great, you put all this on the repository, but it's impossible to get, I have to code for each different date, and then on top of that, give units for a particular variable in one hospital, a difference in the units for the other hospital, and then on top of it, there's possible values that I, as a computer scientist, I'm not aware of, and then I show it to the doctors, and I'm like, okay, that's not possible.
It's the culture shift, right? That we haven't gone all the way back to the sensors and instruments that are observing the data, that capture the data in consistent ways, that we drive that all the way through the pipeline, so that we can actually build these repositories for research. So you're right now where it's such a hodgepodge environment that you're trying to put together a collection of data that's not very interoperable, that's not very comparable, and so that's why we went through the entire pipeline. Yeah, Jim.
But do you think we need to solve Patty's problem first, or you just take all the data as ugly as it is and dump it someplace and start to do?
What we're trying to do is start to build the systematized approach and head towards the instruments. And so we are taking some, as dirty as it is, some of the PICU data, things like that, and starting to not solve it first, but we are trying to figure out how to address some of the problems. And I think Dave, who's looking at the data, will tell you there's a lot of dirty data. There's a lot of holes in the data that we're trying to figure out how do you deal with because of that problem. And so I think over time we're going to end up back at the instruments just because we have to improve healthcare.
Exactly.
But I think we ought to start by starting to put the capability in place. So, yeah.
So I think also one of the things that we as computer scientists and technologists haven't built enough tools for, I think there are a lot of scenarios where you could actually harness the power of the user base to collaboratively annotate and mark up and add comments. This is broken. This is I'm pretty sure this is centimeters and not inches. Simple things that we see implemented in everything from Wikipedia and Facebook and whatever. There are lots of instances of web tools that allow for collaborative work on this, and I think it's very possible that we can build similar things for these data sets. So basically put them out there in whatever form, and as people start to work with them, just make it a lot easier for them to actually let other people know about how they fix things. So maybe allow for collaborative editing, maybe allow for comments, maybe allow for moderation and rating. In some sense, these are all things that we know how to do in some other community. We just haven't made them available in a broad way here. And this is also where I think this notion of putting them in a central place on the cloud or wherever helps, because at least then you can imagine that all these annotations kind of live with that data and everybody gets to see it, right? If instead we just let everybody download the data, then everybody has a little isolated copy, my edits are not going to show up in your instance, right? So I think there's actually a lot of potential there. We just haven't tapped it yet.
So that sounds a lot like source data instead of data forge instead of source forge, right? you're saying I want to create a place that's got a wiki. You can check out the data. You can check back in edits to it. You can do these sorts of things. I mean, maybe that's a suitable model then. Instead of having the code being the thing that's collectively edited and reviewed and such, you're saying that the data is similar.
I think at the highest level, I would agree with that. At a lower level, I would say, for instance, there are a lot of cases where I don't want to check out the data. I might want to directly edit in place. And the granularity will be different and so on. But yeah, I think that kind of rough idea is roughly a good one. I mean, another way of looking at it is if you've ever played with the collaborative features in Google Docs, right? You can open a spreadsheet at the same time as someone else, and you can see where their cursor is, and you can see their comments and so on. And I think a lot of these things, you can imagine having a very similar concept on the data side. It's just that we somehow have not yet done that. And perhaps the problem is just that, right now there's not sort of, like, it's not clear what the market is, so there's not a big commercial interest. And, we just haven't sort of found the right set of researchers to do it on the academic side.
Hey, Jeff.
Having done my thesis on that topic of collaborative analysis, I want to say I think it's not just a technological problem, in the sense that I think you're right in that the technological solutions are well within the purview of what we already know to do. What was hard is knowing what is the right model of collaboration that will allow it to succeed. If the database is filling up with a bunch of junk topics for people who don't know the domain, that's obviously not going to be very useful to science. And maybe that's an easy example to point to, but in general, the ways in which we structure collaborations so that people actually have this accretive growth that improves the quality of the data is very hard to do. And I think that's a really important area for research that really isn't often considered in this space.
Sir?
I think you also have to remember NIH is not a monolith. NIH is comprised of a large number of institutes. And the institutes actually don't get along together as well. They are, in the commercial world, they're individual profit and loss centers. And they don't share standards, and they don't very easily come together to create a set of standards where, regardless of what disease area you're working in, you're going to have a single model that's going to support a data process.
I would take it even further beyond the institutions and down to the actual individual scientific group level as well. I mean, it's the exact same pattern there, which is typically why I would go back to your point. I would totally agree with that. That's basically the reason. It's the difference between Tim Berners-Lee and the semantic web vision, from 1999 that never exactly materialized, to this day. And for instance, this guy's, old company where Facebook tricked us into curating that rich information so they can, operate on it because they let me upload my, photos there and stuff like that. And they do other cool stuff like let me poke people and add my status. They tricked me into doing it, to capturing that rich sort of curated model. And I guess I heard this at a meeting recently. They used the word incentivize, and I think that's the thing that's lacking. So.
I think incentive is a big point, but it's also the structure in which people make contributions.
Yeah.
And it also allows you to do really interesting things where you can have experts and maybe non-experts also start to participate as well.
Right.
Often in different ways. And it's just the scaffolding of that is a hard design problem.
Yep. Absolutely.
Hadoop has been mentioned several times. Which area of Hadoop
Okay, so the question is, what areas can Hadoop be useful? And I feel comfortable fielding this one, in medical data, that is. I try to give some examples near the end of my talk. I'm not sure if you were here for that. Where it is currently being useful today. So one of the easiest ones is sort of literature search, any kind of text mining application like that. It's also starting to be used for rapid search over large collections of genomes of annotations and variants. It's also used for large collections of medical images to allow rapid query of those large collections. It's also used for things like post-market or phase 4 clinical trials. So when you've got a really large population of users, numbering in the millions, where the data volumes are high enough that maybe you're doing traditional analyses, but just at a scale that you're not used to. So those are 4 examples where I think it could be useful.
So certainly we envision using Hadoop in some portions of what we built, but there are a variety of other things that we've also been using. Because, for instance, you need kind of an interactive application, and basically you need a whole slew of different technologies. And the other thing is, we are trying to fit our solution into a problem space where there's legacy code, right? I was saying, there's a lot of MATLAB out there, there's a lot of C, there's a lot of Java, and so on. And our hope is that we can educate people and maybe in some cases help them recode things for Hadoop. But it's not just a matter of like translating languages here. What we're talking about is there's code that was written to sequentially go through a time series that you have to turn into something that's parallel, right? And so somehow it'll have to take segments of the time series and run them on different machines without communication. This is not a recompilation. This is a re-implementation from the algorithms up. Okay, so I don't think Hadoop is definitely I think it's got a lot of great characteristics, and there are a lot of other systems that also have these very nice characteristics that help you scale. But for the most part, they're not magic. They're not going to take code that wasn't designed to be parallel and turn it into code that's gets a 100x speed up, right? There is no free lunch here, unfortunately.
I would say, as someone who controls a budget and purchases software, you're creating the market of software providers, right? So you're deciding the process by which the software will be built and delivered to you. And so the skills that your particular organization has and is able to bring to bear in that market are not the same as everyone else's. So by purchasing commercial open source software, you're contributing money to the development of that open source software. There are other organizations, hopefully, who are able to use that software without the need to acquire the enterprise edition, who themselves are improving and making better. So, you're essentially putting money into a communal pool for the creation and maintenance of that software. And hopefully the notion is that the overall cost of what you'll have to pay is lower than if you were putting that money into a communal pool that's only used by a single organization to develop that software. I mean, that's one way to think about the problem. I think there's a lot of ways to try and justify it, but I'd also push back and say, okay, if you consider that to be bad, well then what? What is the kind of structure that you would prefer as someone with budget who is able to create the processes that deliver to you software?
I would also add, just on top of that, I would encourage that whenever we use the word open source, we qualify it. Sometimes it makes me cringe, when someone says, well, my software is open source. Well, what does that mean? What license are they using? What type of community is it? What type of sort of redistribution rights does it have? There's a whole bunch of different dimensions, to open source software that I think a lot of times, like at least for instance, I know in academia, there's no sort of systematic framework for teaching it, to students. And then at NASA, we're still, grappling with sort of understanding, what it means. So it's not like you can walk around and just talk about open source software. There's a lot of people that still think that just means the GPL, or the software is Linux, and they equate open source in their mind with that. They think that that's open source. So, I think, an understanding of that is really important when you talk about open source. It allows you to deal with the types of things like Jeff has been talking about. It allows you to deal with a lot of the things like we've all sort of, on the panel been talking about, which is how to select technology, how to pick approaches, for doing things, how to understand licensing models, the advantages of certain licensing models, and then how to build expertise in that. how to make sure that, if you don't want to buy the enterprise edition of an open source, software thing because you bought it from some commercial vendor, well, train one of your software engineers to be a core contributor to the most upstream version of it that doesn't cost. And, realize that you paid that cost in training that engineer, to become one of the principals behind it, or a set of teams, to do that. So at some level, I agree, there's no free lunch, even in this, realm, with respect to that. So, at some level, you sort of, the cost is paid. Yeah.
I would also offer up the idea that the creation of standards is what might prevent lock-in. Being open source may empower you to choose your own fate within that system, but you're still, in some sense, locked into your choice without the ability to choose something that adheres to a common standard.
And I'd just like to add one more thing, which I think wasn't mentioned in the list of benefits of open source, but I think is one of the most important things that we saw. In fact, I think in all of the talks this morning and afternoon, which is extensibility and customizability have to be integral to the design of, really all of these things, right? So one of the big reasons open source is so useful is not just, that it's open, it's that if I need something that's not in there, I can actually, at least if I can get the expertise to extend it. And, I think one of the big advances in, all of these platforms that we're talking about is, an acknowledgement that we have to do things incrementally, right? So no schema, no rigid design to start with, and you gradually extend things, right? Customize and so on, right? Access to the metadata and the low-level details as well as the higher-level ones. So, basically, I think across everything, you'll see this common theme. Extensibility, evolvability, don't lock yourself in to one particular target.
Yeah, I want to add one non-functional property on top of extensibility, which is easily for that. Because, Microsoft Excel lets me, extend it by writing Visual Basic, and I can write plugins. And, Microsoft Visio at one point allowed me to write plugins for it. I could extend it, add new things, but they did it in such a way that it was so difficult that I would never, ever do it again. So, easily, I think, is a big thing in open source.
John? I'll also add that as someone who converted a MySQL data warehouse to an Oracle data warehouse, I think the notion of a standard is often used as a marketing tool as opposed to reality. SQL is not a standard in anything other than as a marketing tool. There's these databases differ in such great detail, and things like POSIX, like most file systems, don't follow all the POSIX standards. There's just in my experience, standards are almost always used for proprietary software vendors to convince you that you're not being locked in.
HL7. That's what I heard.
All right, we have 1 minute, so if you've got a question, now is the time to ask it. Go ahead. Yeah, go ahead.
Open source and security. Like, if you're thinking about medical systems, that's like a big deal. So, there's like, well, I always thought open source was less secure.
Why?
Because somebody can have the code. So somebody can just look at
Wouldn't you think that would make it more secure? Because if everyone can see the code, then security holes would seem to be pretty obvious, right? You have more eyes on it than just the people. So there are more people outside of the organization producing the code than there are inside the organization for every organization. So I've always assumed that open source is way more secure.
Yeah, a good example is we use for one of our cancer research portals, Plone. Plone's an open source content management system. If there's a security breach found, it's usually fixed that day because there's such a large community of open source developers who got their eyes on it. So you're getting software releases all the time, and so they're just a great job. They're on it. And so
you reminded me of something just to pass along for that, which is there was recently something found in the Apache web server that was something like that. It was like a big security hole where you could do a distributed denial of service attack. They fixed it in Apache like the same day, but then Mac won't because Mac includes Apache as a web server in their distribution, they're not going to fix it for a while because they release, and you'll find that, in the upstream open source software, if you're one of the sort of people at the vein, they're consuming it. A lot of times you can get the fixes quicker. Yeah. Sure. Mm-hmm. Oh, right. You're right. Yeah, I don't think, so security is a loaded word too, right? Because I could ask you, well, where are you talking about? Are you talking about in the research database? Are you talking about in the file system? Are you talking about in the downstream analysis tool? So, I guess your point is, you have to qualify that as well, which I agree with. Yes, it's, there's different life cycle, for each one of those. So.
Any other questions? All right, thank you.
We have a 20-minute break, and then when we come back, we're shifting gears from